I'm going to talk about design thinking. We found a few quotes quick about thinking. I always love finding something from Dr. Seuss. Just the way he phrases sentences, I get a kick out of. I'll let you read those. But David Kelly, IDEO, another really good source when we talk about sustainable manufacturing and product design. IDEO is a design company renowned for how they use very innovative processes in their manufacturing. And I wanted to address this for just a minute. Fail early and often. That was a mantra in manufacturing and software design for quite a while, and still kind of is. But what it meant was the markets are moving so fast. Things are changing so fast. If you do nothing, you're dead. And it doesn't matter if you fail, because if you fail, you're dead too. But you fail forward. And this quote doesn't have that on there, but it was, a lot of people said fail fast, fail forward fast. Because the market was moving so fast, if you failed, you could realize why you failed and then improve your design and then move on. So we get into this iteration process. We'll talk about prototyping a lot in engineering. You prototype something to see if it fails. So if I'm going to prototype this wrench here, I want to make sure that it turns a certain way and it holds a certain pressure there. Well, I design it, I put the pressure on it, and it breaks. I know I've got to change something. That's a lot of what 3D printing is used for, is building these prototypes and going through that iterative process of design where you are designing something and then you're testing it for failure. And the reason we test things for failure in design is if I test this now when I'm designing it for failure and I find out it fails, I redesign it a couple times and I get the product out and I manufacture it. But if I manufacture this product, if I've got 1 million of these went out the door and they fail, you guys remember Pinto, right? Ford Pinto? Everybody knows the Ford Pinto. Think about what happened there. That Ford Pinto, not only did they have to recall those cars, we're 40 years later, almost 35 years later, more than that, and people still remember it. That stigma is now attached to that company. Design failures are extremely expensive, and that's why we prototype a lot. Now translate that in education. I read more and more about in education, we want to give our students the opportunity to fail. That's part of the reason we want to give them the opportunity to fail. If they fail, how do they handle it? Do they understand why they failed? Do they understand the concept they got wrong? Can they correct what they failed on and move forward? Really applies in engineering. And we talk a lot about that iterative process in engineering going through prototyping. And it's part of why 3D printing has gotten so big is we can literally make these parts the day we design them and test them. Okay, so I want to talk about design thinking, and I want to show you a video. This is a lesson in Edify. So in Edify, what I did is I picked this Manage pull down and picked lessons. And then in the available lessons, typed in STEM space KISD, and I get a list of lessons here. And I want to use this balanced bike design. You can type in balanced bike design up there for search for lessons also. I think this is on page 2 of that. So I picked balanced bike design, go into that lesson. And again, similar to the other ones, we've got a primary resource up here. And then the supporting documents down below that. And in this case, these supporting documents are videos that walk through how to use a software application. And the idea behind the lessons that we create in Edify is that if we're going to have your students use a piece of software, we're going to have a tutorial for the students to use the software. And you all know when you give students software these days, they pick it up pretty dang quick. They're just used to that environment. So we're not burdening the teacher with, okay, you teach about learning that piece of software, your students know it. And this gets back to the concept of guide on the side. You do not have to be the instructor to teach them how to use that software. I had several lessons. I've actually done quite a few lessons in SimCity, the gaming application SimCity. I've never played it. But my students have, and my students know it very well, and I knew what I wanted them to do. Same thing here. We've got tutorials for those lessons up here. So what I want to talk about is that fail forward fast concept of design prototyping. And this is a video from Autodesk, a large manufacturer of design software. Worked for them for quite a few years. Design thinking, let me take that back. I'm going to run the video first, run me, save place. So this is a balanced bike design. So this is a design project that your students would use. This is the first video. It starts out talking about design thinking. And then videos follow to show them how to use the applications.
Can you guys still see it okay, or is there too much light?
The process used to develop products such as a balanced bike and radio-controlled car is referred to as design thinking. It's important to note that although the two products are very different, you can apply the design thinking process to any product. Let's review the 7 key steps in design thinking. They are: understand, explore, define, ideate, prototype, refine, and solution. The first 3, understand, explore, and define, focused on developing a thorough understanding of the design criteria for the bike and the car. For the bike, we need to know where it is going to be used. In this case, it will be in supervised areas such as school playgrounds or parks with smooth surfaces to ride on. The requirement for the car is very similar. It will be in large outdoor areas with flat terrain. Then you ask who will be using the product. In this case, the products will be designed for 2 different groups. The bike is for young children, but the car is for teenagers. Ideate is the stage that we will focus on. Using Sketchbook Pro and 123D Design, we will come up with initial design ideas. This is an exciting part of any design process where you can use your imagination to create products that will appeal to kids riding the bikes or the teenagers using their radio-controlled cars. The prototype, refine, and solution stages follow ideate and transform the concepts into production. With 123D Design, we now have the ability to export the designs to 123D Make or to a 3D printer, so you can quickly turn your amazing 3D designs into a real hands-on project.
Let's talk about this design thinking briefly because I just went through the video. Then I'll talk about those models and pass them around. This design thinking process, so I mentioned earlier, as the project behind your, or the thought behind your project, you might use that form, fit, and function. This is then the process you would use to achieve that. So this is the process you want your students to walk through to achieve that form, fit, and function of the product they're going to design, or machine they're going to design, whatever they're going to design. If you flip over to the second page, the first thing there is understand. And that's where they were showing the kids, we need to understand who our market is, who our audience is. After that is explore. And this could be surfing on the web, but you're surfing different products. What's already available out there? What are some different ideas I can grab? And then ideate, they talked about ideate. At that point, the students are being creative, thinking about different ideas. How can they design this differently? What can they do? And then prototype and refine are similar. They're starting to prototype their things. And now I'll talk about 3D printing. But prototyping can be paper, cardboard, all kinds of different things. You guys seen Kane's Arcade? Y'all seen that video, Kane's Arcade? I'll play that later if we get a chance. Kid in Los Angeles, was it? It's Los Angeles. He created a whole arcade out of cardboard. And he was 9, 10, he was pretty young. So if you've got high school students coming in and saying, oh, what can I do with cardboard? It's an amazing video.
He's making money off of it.
Yeah.
He charged people.
And some celebrity came by and gave him a bunch of money for his arcade, and it's a pretty neat video. So I'll try and run that later. So this is clear, right? So this is one of the processes you can have your students use in product design. 3D printing, I'm actually not sure how much we'll talk about it today, but these 3D printed models, the wrench I have here, I'll pass around. So I think you're all probably seen 3D printing. And basically the way this works, you'll have a model like that in 3D CAD, and then the 3D printer spits out plastic, and it does it layer by layer, and builds it up like this. But one of the things you can explain to your students, whenever it builds these 3D models, you've got this white plastic here as the model material, and this brown plastic is called the support material. And the reason they have that is this white plastic is great model material because it's very durable, it's strong, it's hard, you can really wrench on it pretty good and not snap it. But this brown material is extremely brittle, and it's lousy model material, but it solidifies very fast. So as that it's a little pipe actually that spits a piece of plastic out, it's just a really tiny little dot of plastic. As it's spitting out the white plastic, that white plastic is very pliable, it'll fall over, so the walls of this house will collapse on itself. But when it spits that brown plastic in between the walls, it solidifies so fast it holds the white plastic in place. So the brown plastic is support material and the white plastic is the model material. One of my students, 2 years ago, he won the architectural contest for the state, went on to the national contest. This was one of his designs with Autodesk Revit he used for this. Spent a lot of time, but we were able to 3D print that out. Now, I'm not sure how much I'll talk about 3D printing today, but I might as well address this now, the cost of 3D printing. So in my room, I've got a Stratasys printer. It costs about $20,000. It's extremely robust. It doesn't break down. I can send projects to it all year. And this model takes 24 hours to create the modeler because it's spitting out these tiny pieces of plastic as it goes through. So if I've got 30 students, and each one's going to take 24 hours to do this, it's a lot of time. If my modeler goes down, if it breaks, and I was teaching engineering, this was the main component of our engineering course, I got a big problem because I need to print these parts out. That being said, we've got a lot of cheaper modelers on the market now. MakerBot, some of you probably heard of MakerBot. They've gotten pretty good, but they require more maintenance to keep them running. For my classroom, it didn't work so well because we're doing such a high volume. That MakerBot, the mean time between failure, how often it's going to fail depends on how much you actually use the thing, was really, really small. So we'd have to replenish it and fix it so often, it didn't make sense for us. But in a typical classroom, if you didn't base it on your engineering project, will be based on part on your model. If it was more of, when you get an opportunity, you can use this modeler to test your design. They fit pretty well. They're about $2,000, and they go down, the lower ends go down to $500 now. And this material also costs, this much material also costs about $75. Pass that around. So just for that house was $75. That's pretty expensive. We got a lot of students in the room. The lower end models, under $10, maybe around $5 to do that plastic. A little less resolution, but you don't quite need high resolution because we're not manufacturing these things. We're prototyping. Yeah?
We've used prototypes. We send them to a place that our models and we get reference back. Depending on the material you use, the price goes up. So for us, we needed a higher strength material because we were testing some of the components fit together and make sure they work.
Right.
So that price goes up a little bit. It was about $135 for one of our models, which is also pretty complicated. But we use them at the beginning design stages, and we found a lot of smaller things that we picked up and changed when we went to our tools.
Geez, a lot in engineering, isn't it?
Yeah.
And like Nicole was mentioning, they can use different materials. They can do metal now. Deposition fusion, they can take little drops of metal, fuse those together as they're building the model. So you can actually do some real prototyping because you've got a metal part now. You can test for wear and material strengths. And the expense, if it costs $150 to do a small model, but I'm doing that before it hits manufacturing, so I'm saving hundreds and thousands of dollars if I have an error. So $130 is pretty cheap to get that done.
So you want to hit real quick what you're going to do with 3D PD, or is that another slide or something?
I don't have another slide, but we're going to have professional development on building 3D models, and I'm going to show you a bit today. This is functional. This is how this comes out of the modeler. If you spin that, this does move. So you can build assemblies in a 3D printer and have parts actually move and interact with each other. So you can test beyond just strength and form. Okay, so thinking guide. Great guide to walk through. By the way, I don't want anybody, this thinking guide, I've run across now at least a dozen different design processes. This is one of them. It's a good one. And another real important point, this is especially important for teachers, as you do product design, and if you get a project that's going to last more than a session, it might last longer than a week, you're going to want to assess your students at each one of these intervals, right? Because you don't want those students to go too long on a design project without an assessment. So do they understand the product? How do they explore alternatives? How do they define the project? At each one of those stages, you've got an assessment. And that's another thing I like about this model, is you want to assess students frequently. That guide on the side we talked about earlier, so you're no longer the sage on the stage telling them what to do. You're stepping back and letting them work on their own. Well, you all know when you let students work on their own, you need to have something in place that monitors where they're at and some benchmarks. And this is what I use to do that.